So here in part 2, we're going to go through problems 11 through 20. Again, if you have any questions on any of them, or you need more help, or you're just wondering about a solution or something like that, make sure you take note of those so we can talk about them in our Zoom session on Thursday. So in number 11, if f of x equals x squared minus 3 and g of x equals 2x minus 1, we're asked to find g of f of x. Okay, so we remember that g of f of x, we write it like this, g of f of x, right? So we know that f of x, this value right here, is x squared minus 3. So I'm going to rewrite this as g of x squared minus 3. And so in our function g, we have 2x minus 1. And if we think of x squared minus 3 as just kind of like an x, we would rewrite this as 2 times x squared minus 3 and then minus 1, right? So simplifying it, 2 times x squared would be 2x squared. 2 times minus 3 would be minus 6, and then minus 1. Now we can combine our like terms, which would be minus 6 and minus 1, and our correct answer would be 2x squared minus 7. So hopefully you got that one right to start us off today. Now, number 12, it says find f minus g of x if we know that f of x is x squared plus 8x and g of x is 3x minus 5. Okay, so we're looking for f minus g of x. So that's really just f of x minus g of x, right? And so we can just plug in our functions. So f of x is x squared plus 8x, and then minus. And you know what? It's probably a good idea to use parentheses just so we don't miss a negative or something like that. So minus 3x and then plus 5. So combining, again, our like terms, we have x squared. I don't have any other x squared, so I'm just going to write that as x squared. Then I have 8x minus 3x, so that's going to be 5x. And here's where the negative's kind of important. We have no constant term here, so nothing. Minus 5 would be minus 5, right? That would be minus 5. And so the correct answer to this one would be C, x squared plus 5x minus 5. If you put down letter B, remember the minus sign has to be distributed to minus 5 as well. Okay, let's look at number 13. Which pair of functions are not inverses of each other? Now, there was a way that we checked inverses, and what that was is we would put in like 2x minus 9 or plus 9 in for the x in this one and saw if something canceled out. Now, looking at these ones right now, I'm wondering if there's one that kind of sticks out to you or one that you felt very confident about when you were putting in, looking at your options. Okay, so let's start with letter A first off. And we're going to say, all right, so 2x plus 9, I'm going to plug it in for that x right there in h of x. So I'd say 1/2 of 2x plus 9, and then minus, minus 9 right there. And so then if I distribute the 1/2, right, 1/2 to that, 1/2 to that, I'd get x plus 9/2 minus 9. And when I try and simplify that, I'm getting x and then minus 9/2 or 4.5. Well, that's not just x, right? So we know that these two, g of x and h of x, are actually not going to be inverses of each other. Now, if you're confused on that, let's look at another one that we know for sure is. Okay, so an easy one would be letter B, okay, but we can look at a more difficult looking one. Let's look at letter C. So 3x minus 6 and 1/3 plus 2. So if I take 3 times, okay, actually, you know what? I'm going to take the top one, g of x. I'm going to put it in for x right there. So 1/3 times 3x minus 6 and then plus 2. So we're going to distribute, right? 1/3 times 3x would just be x. Okay, 1/3 times minus 6 would be minus 2. And then plus 2, when I simplify, I get just x, right? So when I do that, I have a good idea that those two are going to be inverses of each other. Now going the other way, I'm going to take h of x and put it into this one. Okay, and so I would say 3 times 1/3 x plus 2 and then minus 6. So 3 times 1/3 x would just be x, and then 3 times 2 would be plus 6, and then we have minus 6. Those cancel out, and I just get x for both of them. So for sure, C are inverses, and you could pause the video and verify that the other ones are inverses of each other, or I guess you could just take my word for it. But C and B and D are all inverses, where A is not. Okay, number 14, write the fifth root of m to the third as a rational exponent. So we said, okay, when I have a fifth root, that would be to the over 5 power, and then I have m to the third over 5. So the correct answer to this one would be C. Hopefully that's an easy one that you could get right correctly very quickly as well. All right, number 15. It says, simplify 5 over 2 minus the third, or square root of 3. Now, how we got rid of square roots on the bottom is we multiplied by our conjugates. And we did this back when we looked at complex numbers. So 2 plus the square root of 3. I'm going to multiply the top by 2 plus the square root of 3 also. And so when I multiply, 5 times the top is going to be 10 plus 5 square roots of 3 all over. And then 2 times 2 is 4. 2 times the square root of 3 would be 2 square roots of 3, right? And then negative square root of 3 minus 2 would be negative 2 square roots of 3. And finally, negative square root of 3 times a positive square root of 3 would be minus 3. And so then you'll notice, simplifying it out, 2 square roots of 3 minus 2 square roots of 3 go away. And 4 minus 3 is actually just 1. So I get 10 plus 5 square roots of 3 over 1. And so we normally don't write it as over 1. So the correct answer to this one is A. Okay. Number 16. Simplify the expression t to the 3/4 over t to the 1/5. Now, we looked at a problem earlier when we were dividing, and we said, okay, well, what we do is we end up subtracting the exponents, right? So 3/4 and then minus 1/5. Now, I can't do that right now. Now, there's a couple different ways you could do it. You could find a common denominator. The common denominator between 4 and 5 is 20, right? Otherwise, if you wanted to take maybe the easier way out, and that's okay if you do, you can actually just go to Desmos, right? And you can say, okay, well, what is 3/4 minus 1/5? And it's going to give you a decimal, or check it out, it'll change it to a fraction for you. It's literally 11/20. And so I could just write this as t to the 11/20 power. And check it out, that's actually just B. So the correct answer to number 16 is B. And all you have to know is to subtract the exponents, and then you can do it right in decimal, so it'll solve it for you. Take the easy way out, okay? All right, let's look at number 17. It says to solve that radical inequality. So what I'm going to do to solve that is I'm going to start by adding 1 to both sides, right? I have to get rid of that minus 1. And so I get the square root of 3x plus 6 is greater than or equal to 6. Now, I see I have a radical that I can undo. I square both sides, right? And so I get 3x plus 6 is greater than or equal to 36. And then now, easy, this should be like what we did the first chapter. We subtract 6 from both sides. We get 3x is greater than 30, which means x is greater than or equal to 10. Now, you'll notice that is C, right? But we also have to remember that we cannot have something underneath the radical that would be negative. So over here on the left, we're going to say 3x plus 6 has to be greater than or equal to 0. And so we subtract 6. We get 3x has to be greater than or equal to negative 6, which means x has to be greater than or equal to negative 2. So we're actually bounded between negative 2 and 10. So the correct answer to this one is B. All right, let's look at 18. 18 says, when inflation causes the price of an item to increase, the cost of C, or the cost C of the original cost, is related by the formula C equals something. We have it kind of cut off there, which doesn't really help us. And it says where R is the rate of inflation, which we see that we have an R right there, and N is the number of years. Okay, that's N right there. Okay, so what would the price of a who even knows, right? Probably $3,000. I'm guessing it's $3,000, right? $3,000 after 6 months at 6% inflation. Okay, so we know R is 6%, and 6 months would be the number of years. Well, if we have 6 months, that's how much of a year, right? So let's write down our values. Okay, so we know for sure our original amount. Okay, so we're actually going to call that P. All right, principal is 3,000, right? Okay, so and I'll rewrite our formula. That's going to be C is equal to P to 1 plus R to the n power, right? I'm guessing that's what it is. All right, so we know P is 3,000. We know R is written as a decimal, so that'd be 0.06 or 6%. And N is supposed to be years. Well, 6 months is 1/2 of a year, right? So what we're going to do is we are just going to plug this in. So 3,000 times 1 plus 0.06 to the 1/2 power, okay? So this, check it out, is just something we can put into Desmos. So let's do that. Okay, so we go to Desmos and we say, okay, so 3,000 and then in parentheses 1 plus 0.06 and then to the power of 1/2. I get 3,088.69. So I go back here, 3,088.69, check it out, is C. Okay, so we know for a fact that C is the correct, or how much it would cost in 6 months if the original price was $3,000. Okay, all right, let's go check out the last two problems. Number 19. Number 19, it says use a calculator to approximate the third root of 160 to 3 decimal places. Hey, that's super easy. That's literally saying type it into your calculator and tell me what you get. Okay, so we'll do the third root of 160 is 5.4288. So 5.4289 or 5288 would be 5.429. So D is the correct answer for that one. All right. Finally, the last one, number 20, domain and range. So remember, domain is my X values. Okay. And Y are my Y values. My range is my Y values. Okay. So if I'm looking at this, okay, my X values start at -4 and go on forever. So I would say that X has to be greater than or equal to -4. Okay. My Y values, Y starts at 0 and pretty much goes up forever. Now, it looks like it kind of stops, but it does. So it's greater than or equal to 0, right? And so if I look at this domain, we use a kind of goofy notation. It uses those, they use these squiggly brackets. And so this is defined as, if you wanted to know a little bit of high-level math here, that would be the set X, the variable X, such that X is greater than or equal to -4. That would be my domain. And then my range would be some variable Y such that Y is greater than or equal to 0, right? greater than or equal to 0. And so if I look, which one of those shows that? It would be B. So the correct answer to this one is B. All right. So hopefully this half was even easier than the first half. If there were some tricky parts or whatever, like I said, make sure you write those down so we can talk about them during our Zoom session so that you feel confident when it comes time for our test on Friday. So good luck and have a great rest of your day.